Hey, what's going on, folks? All right, so I wanted to try and cover some of this information in Chapter 1, and I know that this is just just an avalanche of information in the very first week. So let's see if we can cover some of this information and clear up some of the confusion. Now, just for clarification, this PowerPoint presentation has 56 slides in it. I'm not going to go through all of them because otherwise I'll be sitting here with you for about 2 hours. So I'll try and breeze through these carefully and and give to you what's going to be important out of the chapter. So if you have any questions after that, I'm sure that I've missed something that you might have questions about. Please let me know. Okay, and so these are just some of the basic definitions, and I'm sure that you guys have read this already. Hopefully you have. A database is just an organized collection of logical related data, and those data formats can be of a variety of formats. And right now we're working a lot with object relational databases, and we'll get into that later in the term. But so these are two important terms that you need to make sure that you're very clear on. There's a difference between data and information, and data is basically just bits of or values that are stored in a particular structure, a particular sequence, and then information is are those values put together in a format that is presentable to human eyes and human brain. And then the metadata is data. The text describes it as data that describes the properties and context of user data. So effectively, all that is data about data. So it's best to remember it that way. So if you look at this figure, this has a collection of data that is names, IDs, the majors of the students and their GPA, and that is enclosed in metadata, if you will, that kind of describes what that data is about, which provides you information that on the data from the database, if that makes sense. So the text goes into pretty great detail about the disadvantages of some of the old file processing systems that were used in the past, and I don't think it's necessary to spend a great deal of time on that. I think it's pretty obvious some of the disadvantages of duplication of data, program data dependency, so on and so forth, and the amount of processing power that is required to handle those kinds of file sizes. So this is kind of an image of that data duplication issue. So there's one file. Oops, sorry about that. There's one file here that is the customer master file that's being used by the order filing system, and then there's another file over here called customer master file that is used by the invoicing system. And of course, these are two different files, and the people that are responsible for maintaining those files are responsible for maintaining to ensure that the information contained therein are identical in both files. So of course, that's a huge task to make for one person to make sure that all that is done. And typically, they have multiple people to cover several different file systems. So of course we also get into the advantages or the database approach itself, and it talks about a central repository of shared data, and that's rather than having duplicate files for different systems to use. And the data contained in the repository is managed by a controlled agent, usually the database management system, and it's stored, of course, in a standardized and convenient form, as long as the database system was engineered properly from the ground up. That's pretty important, and we'll get into that later on in the term. So this kind of demonstrates how this is set up, and this is in comparison to the image for the file system that we saw before. So we have different database access systems, or different applications that access our database management system, and it all goes to a central database or a repository to get the data from one location rather than sharing those files. Okay, and this we also discuss some of the risks and potential disadvantages of converting to a database system, and that's converting from the antiquated or the older file system. So of course, if you move into a database environment or a database management system, you're going to need people that are trained to manage that kind of environment, and of course it's totally different from those folks that were handling the file systems. So and beyond that, the installation and management costs are pretty high, but once those initial costs are invested, then it's the sustainment is really the only thing you have to worry about. And the sustainment includes those specialized folks that know the databases and the database management systems to control those, as well as some pretty elaborate backup strategies. And it's very, very important that the data is backed up, and that you test that the backup and recovery on a regular basis, because and I can tell you from experience, if you don't test that recovery portion of the backup and recovery system, if something were to happen that you have a catastrophic failure on your system when you get the system back up and you try to restore that data, and you don't have a method to restore that data, you're going to be in a world of hurt, and your organization is going to be looking for answers on that. Okay, so we're going to get into some of the areas that I think a lot of people had some issues with, and it's pretty important that we understand these concepts and how they're used. So the text covers a different variety of data models. The graphical system capture, capturing natural and relationship data. The enterprise data model and the project data model are the two that we'll primarily be using, and we'll get into the details of both of those a little later on. This is where I want to stress some differences here. So we talk about entities, and the entities are used in those data models, and I want to make very clear that the entities are totally different from tables. We don't get into tables until we get further down into the development cycle, and we'll talk about that a little later. But at this point, when we deal with the data models, which we're creating right now, we're just dealing with entities. Don't worry about the tables and the data that's going to be contained in those tables. Don't worry about that at all. Or more specifically, don't worry about the queries that are going to be applied to that database, because we don't have a database at this point. All we have are the data models. So, and those data models are used to plan the database around the data models, and you'll see later on that those data models can evolve through the development cycle. And also, the relationship between those entities is very important to understand. So typically, we will be dealing with one-to-many and many-to-many, and there's such a relationship as one-to-one, but that is rarely used, so we'll not be using that in this class. And there's no such thing as a 0 to 1. So if it's a 0 to 1, the entity on the 0 side doesn't need to exist, because there's nothing coming from it, right? Okay, so and we'll also learn here in just a little bit that the many-to-many relationship, the relational databases themselves, when you start looking at the entities and how they're designed, they really don't work with that communication between the entities. So we'll see how to break those apart and make those many to many relationships, break those down into two many to one relationships. So, and in this term, of course, we're talking about the relational databases, and that when we get into the relational databases, that's when we'll start talking about the tables and the relations between those tables, as well as the primary keys inside the each table. Each table itself, and the foreign keys that's brought in by that relationship to the other tables. Okay, so let's take a look at this. As I mentioned, the relational database has a hard time dealing with a many to many relationship. So if you look at this first model, which is it's an enterprise data model, we have a customer entity, an order entity, and a product entity. And you'll notice that the relationship between the order and the product entities is listed as many to many, and that's okay in the enterprise data model. But then when we move into the project level data model, that's when we start moving closer to building our tables. Now we're not at tables yet. We're still using entities. But notice what's happened. We took the order entity and broke it up into two different entities. There's still an order entity, and then there's an order line. So the relationship between the order entity and the order line entity is now one to many, and the relationship between the product entity and the order line entity is also one to many, and that's to replace the many to many relationship between order and product in the enterprise data model. So let's take a look at how that works. So the relationship between customer and order. So this description indicates that one customer may place many orders, but each order is placed by a single customer, hence the one-to-many relationship. And likewise, one order has many order lines, which means that it could have multiple items on that order, but each order line is associated with one single order, and again, that's a one-to-many relationship. And the relationship between product and order line indicates that one product can be in many order lines. Each order line refers to a single product. So again, that's a one-to-many relationship, and that is to replace the original many-to-many relationship between order and product that we saw early on. So, and we'll learn more how to do that in future chapters. So now one thing that I want to mention before we move too much further is that it's important to analyze the situation very carefully to determine what entities you're going to need, and the best way to determine the entities that you're going to define is to identify precisely what data that you need to collect. So there were some people that had some problems with the recent assignments and what data needed to be captured and so on and so forth. Now don't try and invest too much time in a lot of this at this point. Typically when you start working on a large project, you'll have a team of people that identifies that the data that you need. But don't try and create entities just to create entities. All I need you to understand at this point is the definition of the entity itself and the relationship between those entities, and how to define whether it's going to be one to many or many to many, and how to the direction you need to move in to get away from the many to many relationship. Okay, so I don't really want to spend a whole lot of time on this figure. This is the components of a database environment. This is all hypothetical, of course, but you'll notice that that one of these blocks here contains case tools, and that is computer-aided software engineering. And these things are really, really cool because you effectively put the information in there in the system that you're going to need to identify the entities, and the data is going to be stored, and so on. And there's a great deal of detail that you need to put in there, but once it has everything that it needs, it effectively writes your SQL for you, and they're really, really cool. However, prior to using those case tools, it's pretty important that you understand the SQL that's happening back behind the scenes. So you might know so you'll know how to fix it in case something breaks. Okay, so I wanted to spend some time on this. This is our enterprise data model, and this is important because this should always be the first step in the database development process. Um, this is going to capture all of the data that you're um, going to contain within your database system. And now you'll probably get some more information later on through the development cycle, but it's very important that you develop a very detailed enterprise data model first before you go any further. And it specifies the scope and the general content of what the end system is going to contain. And now it's important to note that this bullet says that the overall picture of the organizational data at high level of abstraction. So that means that again, we're not going to get into how the queries are run against the data, or even the data that's going to be the specific data that's going to be contained in the database. So we're doing this at 50,000 feet, saying, okay, we're going to collect the information that's in this system, and contain it all in our resulting database system. We also want to make sure that we identify the relationships between those entities and define them correctly in terms of the cardinality, or the one-to-one or one-to-many, and how to resolve that many-to-many. And of course, the descriptions of the entity types, and the business rules, which are going to be very, very important. And again, we'll cover that later on in the term. So there are two approaches that we're going to cover, certainly in this chapter and in follow-on chapters, to develop our database systems. The first is the system development lifecycle, and then prototyping. And both are somewhat cyclic in structure, and we'll see how both of those worked. Now, it's important to note that the SDLC can be very time consuming, but it usually results in some pretty detailed database management systems. Now, the prototyping, on the other hand, again, that's another cyclic type system, where you develop one system, and then you take notes on how that current system is functioning, both from the performance standpoint and from inputs from the users, and make changes on the operation, the production environment. And there are a lot of agencies that don't like making changes to the production environment, because really bad things can happen. But you know, it's going to be up to you how those changes take place. So these are the steps involved in the SDLC, and I don't want to go into great detail on these, but it's pretty important that you understand what happens at each phase of this process. So I'll let you go through that in the text, and it's got some great instruction on how to do that. But it's important that you go through these through this term as we start putting these database systems together. Now, as you might have read already, we're going to be spending a lot of time on the Pine Valley furniture company, and it's going to be our system that we're going to develop the database for, and we will use this this SDLC to develop that system. And again, there's the prototyping environment, which effectively is you identify the problem and put a system together and put it in place and put it in production, and as it's being used, you identify performance improvements or improvements to the data that is available or the data that's being processed from all aspects, and make cyclic changes through the through the life of that database environment. Again, there are a lot of organizations that do not like making changes to the production environment. That's a bad idea, and depending on what which organization actually deals with. But so the use of either of those development systems is going to depend on that environment. So real quick, I wanted to go through some of these database architectures. This has a hierarchical database model and a network database model, but more importantly, this is the relational database model, and this is what we're going to be using to put together our database through this class. And you'll notice that there is a primary key that identifies identifies each attribute in that table. Now at this point we're talking about tables within the database and specific data, and that primary key is used in another table that the previous table has a relationship with, and that primary key is used as a foreign key, and that's how it establishes that relationship. So, and we'll get into that later on. Now, as I've mentioned, we really don't get into the development or writing of SQL code until week 6, and the term's almost over, and you guys are tired of dealing with me probably and the different types of data models. So I definitely recommend that you get out there on the Nova website and get logged in, and maybe skip ahead to through this text, or find some other sources and maybe create a table here and there, throw some data in there, and see how that stuff works. Set up primary keys and foreign keys, and see how that relationship works as well. So this was one thing I wanted to cover real quick. The text talks about the different types of database structures, and you have a two-tier database model, which you see that sometimes, but not very often anymore. Typically what you're going to see is something like this, where you have a web server that is basically the interface to the back-end database, and all the transactions take place on that back-end database through that conduit of the web server, and you know, it's completely accessible from everybody that needs the information from that data, or from the databases rather. And if the web server is set up properly, the folks that manage the web server and the interface to that back-end database can set up the proper views and web pages and all that to provide each user the data that they need. So in that regard, this is going to be our computer system for Pine Valley Furniture. And again, we've got a web server that is the interface to the customers, or the end users, whether it's a customer or sales or accounting. And now there's a few machines that have a direct interface to the database server for whatever reason, but this is going to be the structure for our database model at Pine Valley. And again, get very familiar with Pine Valley, because that's our shop, that's our store. So now that's pretty much all I have for this chapter, and I'm sure, again, like I said, there are 52 slides, and I skipped through a lot of those, but I tried to cover the important points and some of the difficulties that people were having up to today in this first week. So if you're still confused on anything, please let me know. And I'll certainly address it for you. And by the way, several students have already noticed that if they submit their assignments early in the week, they'll be more than happy to go through the assignment and offer some suggestions on how to improve it before submitting the final grade come Sunday evening. Now, once again, the assignment is due Sunday evening. If it's turned in past Sunday at midnight, you're not going to get credit for it. So good luck on that, and it shouldn't be that big of a deal. It's a pretty simple assignment. So again, let me know if you have any questions.